Cyber threats have never been as impacting as today. New regulations like the EU's CRA will impose manufacturers to address new security requirements. This is where OneScout comes in as a new open source vulnerability lifecycle management tool. It will help you detect and manage vulnerabilities on your software bill of materials. As an input, OneScout receives multiple SBOM files formats that list what components are used in your product. The dashboard presents the evolution of vulnerabilities detected in your SBOM. This analysis was run on NXP's IMX8MP EVK demo Linux distribution. It was generated with Yocto and contains many graphical packages. We can see that most historical vulnerabilities have been fixed on Linux. Let's filter out those fixed vulnerabilities. The remaining vulnerabilities are marked as pending. The dependency versions were detected to be vulnerable, but we have to determine whether the specific conditions of these exploits do affect our product or not. The panel on the right shows that OneScout is capable of aggregating multiple vulnerability detection sources. In our case, Yocto's CVE check detected most of them, but Gripe found additional ones. Vulnerabilities are sorted by severity so that we can focus on the most pressing ones. As we can see, hundreds of vulnerabilities might be affecting our software. We will see how OneScout allows us to manage them along the product's entire lifetime. Let's now head over to the Packages tab. The Packages view lists installed dependencies as well as their versions. We can see here how many vulnerabilities were reported for every package. This view aggregates the multiple SBOMs we provided to OneScout while resolving duplicates. OneScout is compatible with many SBOM formats like SPDX and CycloneDX. The Vulnerability tab is where the analyst can review and triage vulnerabilities. All detected CVEs are listed here along with their affected packages. By clicking on a vulnerability, we can get their full detail from the NVD database. This contains a description as well as their severity score and links for further information and patches. This specific vulnerability was marked as patched by the Yocto build system because our version is unaffected or because the Yocto maintainers have applied a patch. Let's now search if any issues were found with our SSH server. We will sort out all vulnerabilities already resolved. This vulnerability is in pending analysis, so it might affect our product. The CVE view reports an issue in the ping implementation of our OpenSSH version. It is now up to our analyst to decide whether this vulnerability does indeed affect our product, in which case we will have to fix it, or explain why it would not be exploitable for this device. If we have manually backported a fix, we can also mark this issue as resolved. When marking this vulnerability as not applicable, we need to add a justification. Either the component is not present or we have disabled this configuration. Maybe our environment also doesn't allow for this exploit to pass through. Here, our analyst explains that our device is protected by a firewall which does not allow SSH ping messages to pass through. Hence, we are safe. Once all potential vulnerabilities have been assessed, we should head over to the Export tab. Here we can generate reports in multiple formats to leverage the data collected by OneScout. A summary of all vulnerability metrics can be exported in PDF format to send it to management or in a machine interpretable CSV file. We can also convert our collated SBOMs into SPDX or CycloneDX format. The manual vulnerabilities assessment is carried over between OneScout scans. It is internally stored in the OpenVex standardized format. OneScout offers us to export it if we want to reuse it in other compatible tools. While the web UI is very convenient to display and manage vulnerabilities, maintainers might also want a more automated approach. OneScout can also be started in a non-interactive mode, compatible with CI infrastructures. A scan can thus be run regularly to match newly reported CVEs. A conditional expression can be written to make the CI pipeline fail and produce an alert based on new vulnerabilities, CVSS or EPSS scores. Let's now run this command line utility. We can now see OneScout in action. After updating the vulnerability databases, OneScout is able to merge our SBOMs and analyze the vulnerabilities from the multiple sources we have configured. The analysis is now complete. We have access to the exported reports in the outputs directory. OneScout has produced the same reports that we could generate from the web UI, which could now be saved as artifacts of our CI pipeline. For instance, the summary report lists the most severe vulnerabilities which are pending for analysis. Developers may now review the detected CVEs from the reports or bring up the web UI. OneScout is available to download on GitHub and the Docker registry. As an open source solution, it can be fully self-hosted with no hidden fees. Head over to the repository to try it out yourself. We would also greatly appreciate your feedback. Post issues or pull requests, or star the repository to let us know of your experience. OneScout is developed by Savoir-faire Linux, a leading open source software engineering and consulting firm. If you need help to secure your product or handle the vulnerabilities discovered by OneScout, discover our cybersecurity services on our website.